Okay, so I'm on page 17 of our Unit 2 packet, and I'm looking at the sampling distributions for proportions example. So I'd like to do one of the, well, maybe two of the examples with you, but we'll do one at a time. So we'll do number 9, and then I'll stop the video and I'll do number 10. Okay, it says according to a national survey, so that's the whole population, 71% of millennials are either engaged or actively not disengaged, in the workplace. If we were to randomly survey 100 millennials with jobs, what is the probability less than 65% of them would not be engaged at work? Okay, there's a lot of information there. But first and foremost, there is the beginning of the question, what is the probability? So I want underneath of that is where we want to write that that's the beginning of where we start to use normal CDF. Normal CDF is used to answer questions about finding probabilities of events. So what is given before that should be the population proportion and the sample size, the two things that we need to be able to proceed to create our sampling distribution. So let's look above of where before it says what is the probability. Right at the very top, it says this is a national survey, and 71% of the millennials in the survey said, yes, I'm not engaged at work. So that is our proportion. This is a yes or no question. Are you disengaged at work? And 71% of them said, yes, they are. Now we're looking for the sample size. So we're looking for that key language that tells us that this was randomly sampled, because that is really important in in creating a sampling distribution, that we do this randomly. So that random survey is of 100 millennials. So that tells me that N is equal to 100. Okay, now that we have that information, we're going to focus on part A, which should be telling us to make a sampling distribution first. And then in part B, we're going to be asked to use the sampling distribution to actually answer the probability question that was asked. All right, let's go to part A. First, find the mean and standard deviation for the sampling distribution for the proportion. Oh, look at the language. The proportion of millennials who are not engaged in the workplace. So the language here is even saying this is a sampling distribution for proportions. So underneath of that, I'm going to use the notation we just learned in our notes. That is P and then the square root of P times 1 minus P all over N. That's our mean first, comma, our standard deviation. So those are two different values separated by a comma. That language is telling us that first we want to find our mean, and then we want to find our standard deviation. So let's do that separately. The mean is P. So based on what we got from our paragraph above, we know that P is 0.71. Now let's work on finding the standard deviation. The standard deviation is P times 1 minus P all over N underneath of a square root. So let's set that up. I know this looks intimidating, but we got this. It looks like this. 0.71, 1 minus 0.71 all over 100. And if we look in our calculator, what we can do is we can actually hit second and then x squared, which gives us the square root button. And you can put everything in the calculator just like I wrote it. So you can start with a 0.71 parentheses 1 minus 0.71 divided by 100 and then hit enter. And as long as you start with that square root button, everything should be included underneath of that square root. So once you do that work, I want you to check that you get the same answer as me. When I did that, I got 0.0454. So do that work, pause the video, make sure you have the same answer as me, and then we can put this all together in that formation above with the capital N. So now we know our mean and our standard deviation. So this means we have a normal model where the mean is 0.71 and the standard deviation is 0.0454. So that is the normal model that we need to use to answer any of our follow-up questions below. Let's look at letter B. Now it says, using your sampling distribution, that's the normal model we just found, from part A, what is the probability? So that says to use normal CDF, right? That's that language. Here's our keywords. Less than 65% of them would not be engaged at work. Okay, so again, this language right here, what is the probability, is telling us to use normal CDF. And this language is telling us whether we are being given an upper bound or a lower bound. So it looks like less than 65%. So if we want less than that, then that implies that 65% is the upper, but we need to represent that as a proportion. So we actually need to write that as 0.65 is the upper. They are not providing us with a lower bound. So as we know from 7.1, 7.2, and 7.3, if we don't have a lower bound, we need to use a large negative number to represent our lower bound. So we're going to do normal CDF. Our lower bound is going to be negative 99999. I'm sorry, 6 of them. And then our upper bound is going to be 0.65. Our mean is 0.71. And our standard deviation is 0.0454. So for us to enter that into normal CDF, we want to go to second vars, just like we did for the rest of chapter 7. Normal CDF is right there at option number 2. Go ahead and enter all that information. Pause the video if you need to. And then our final answer is 0.0932. I'm going to stop this video and I'm going to record the second example as a second video so it's not too long. Let me know if you have any questions at all.